Example 7. In 2004, a school population was 1,001. By 2008, the population had grown to 1,697. Assume the population is changing linearly. How much did the population grow between the year 2004 and 2008? The change in the number of students was 1697 minus 1001, which is 696 students. For letter B, how long did it take the population to grow from 1001 students to 1697 students? So the number of years was 2008 minus 2004, or 4 years. What is the average population growth per year? This is a different way of asking us what is the slope of this linear equation. So we're going to take the change in the number of students we want to know the change in the number of students per year. So when we say the word per, that's where we draw the fraction bar. So number of years. So that would be 696 over 4. And so that simplifies to 174 students per year. So that's our slope. Letter D, what was the population in the year 2000? What we're going to do is build a model that we can use to predict population in other years. And so we're using the year 2000 as the y-axis, and we're backing up to figure out what the y-intercept is. So in the year 2004, the population was 1001. And if we go back to the year 2000, we have to subtract 4 times, we're assuming that there was an additional 174 students each year. So let's do that. 1001 minus 4 times 174. And we're getting that there were 305 students in 2000. Now for letter E, we're going to find an equation for the population of the school t years after the year 2000. So we'll think about the general y equals mx plus b as our formula. M is our slope that we found back in letter C, so that's going to be 174. B is the number of students that we found in letter D, so this will be plus 305. And then I'm going to change my variables to match what is listed here in the problem. I want my output to be population. I want it to be related to time, the number of years. And so then what I'm plugging in for x is t, the number of years after the year 2000. So this is our equation. Now we can use this equation to predict the population of the school in 2011. We're being asked to plug 11 in for t. And then we'll just plug that into a calculator. And I'm getting, oops, I did something wrong because I got a very crazy number. I'm getting that in the year 2011, the population was 2,219 students. Let's look at a different example that uses linear equations. For example A, when hired at a new job selling electronics, you're given 2 pay options. Option A is to have a base salary of $14,000 a year with a commission of 10% of your sales. Option B is to have a base salary of $19,000 a year with a commission of 4% on your sales. We want to figure out which one of these is the better option, and it's going to be dependent on how much we can sell. So for option A, we'll say that the total amount that we're going to get paid, I'll just say P, based on our number of sales, we're going to get 10% of our sales plus 14,000, right? And the way to write 10% is to change it to a decimal. We change percentages to decimals when we use them in math equations. Okay, so that's option 1. For option 2, we would have 4% of our sales, so that's 0.04 times S. And then the base salary is 19,000. So what we're going to do is we're going to say, well, when do we think that, when is one of these options better than the other? Let's see what happens if I take option A and say, well, how could option A give me more money than option B? So I'm going to put 0.10x plus 14,000. And I want to know, oops, that should be a S, 0.04S plus 19,000. I want to know, what does S have to equal for A to be the better deal? So what I'm going to do is I'm going to subtract 0.04S from both sides to start. So then we'll get 0.06S plus 14,000. And then let's subtract 14,000 from both sides. So 0.06S is greater than or equal to 5,000. And then we'll divide both sides by 0.06. So then S is greater than or equal to, this is a lot of 3's. So what this is telling us is that option A is better if we can make, if we can sell $83,000 or more of product. So the question to ask would be, what is the average sales for a person starting out in this job? And if they say, oh, people typically sell about $100,000 worth of product, well, then we would go with option A. But if they say, well, most people start out selling about 50,000, then maybe we would go with option B. So again, this is an example of how we can use linear functions to help us figure out better options and then also predict behaviors in the future.